All right, welcome back, and this is a part 2 of the lecture, chapter 8, subnettings. All right, so I want to say it again. You can see that we borrowed 3 bits, and by our borrowing 3 bit, our subnet mask is no more 24, 8, 16, 24. It becomes 27/27, and since we only took 3 bits, we didn't took 8 like we did over here. So as a result, this 255 is really 1 plus 1 plus 1 plus 1. All the 7-bit will give you 255. But in this case, we only took 3. If you took 3, then your new custom subnet mask will be 128 plus 64 plus 32, which will be 224. All right. In the next one, this is another video that also is included in the material that you have. You can see this is Class B, and I am not going to do Class B. As a matter of fact, I'm going to only focus on Class, Class C, because at this level, I think it's a little easier. However, if you have a Class B, then you know that your network is divided into 2 parts. One part is a network ID, and they're 16-bit, and the other part is a host ID, and they're also 16-bit. So you have 16 this side and 16 this side. Put them together, and you will get 22. In this case, we have, whatever reason, we had what is the magic number here? They said we had borrowed 23. All right, we need 23 bits, so we have 8 here. We have 8 and 8, 16, and you need 23. So you're going to count the number. We have to 16, 17, 18, 19, 19, and 20, 21, 22, and 23. All right. All right, here we're going to move into what we call classless IP addresses. Classful IP addresses will always have /8, /16, and /24. Classless, however, will look something like this. Will look like /25, /27, and so forth. Now the question is, how do we get them? Well, this is one in this example. I'm going to show you. We're going to borrow. Here is first how a classful IP address look like, and we're going to borrow. We will borrow 1 bit. So by the way, what class of IP address is this? This is Class C. How do I know it's Class C? Class C, because I know Class C because by looking at the first octet. Usually the first octet will define which one is a Class A, which one is Class B, and which one is Class C. And this is what we did in chapter 7. Well, 192 is between 191 and 223, and that's the range that is reserved for Class B. So given a class C, given a Class C over here, we need to create networks, and we need to borrow some bits from the host. So here is a Class C subnet mask. You can see 255, 255, 255, and we have 8 bits for the host. We're going to go, this orange one, we're going to go and steal it. We're going to go and borrow 1 bit from the host and bring it here to the network to create a custom subnet mask. Well, it happened to be, if you create 1 bit to the power of 1 is 2, you will have 2 subnets. Those subnets are, the first one is 0, subnet 0. Then you're going to have 192.168.1.0. All right. And the second one will be 192.168.1.1. What's this 2 network have in common? They will all have the same subnet mask, and they will all be in the same network. They will all be in the same network, which is 192.168.1.0/128. 192.168.1.128. That will be the new custom subnet mask. You may ask, where did you get that number from? Well, since you borrow only 1 bit from the host, and the first bit is the highest bit is 128. So this is 128, 64, 32, 16 till I get to 1. So the highest bit in the subnet mask is 128. No, so as a result, since we borrowed 1, we have a new 1 network, and our network now is a /25, is no more /24 Class C, and by doing so, now we have a new subnet mask, which is 128. The new subnet mask is no more 192. I'm sorry, 192.168.168. That one. It'll be now be one. It'll be the new. I'm sorry. The new custom subnet mask is no more 255. That 255. That 255. That 0 as it was before. Now it's 255. That 255. That 128. All right. Let's take another example. Imagine you were given the same network 192.168.1, and you were asked, you have this router over here, and you were asked to create two network. One network for this side of the network, which is 1, and the other network is here. Well, how many bits you need to borrow in order to create two subnet, two network? Well, you just need, for now, you just need to borrow 2. By borrowing 2 bits, right? By borrowing 1 bit, as a matter of fact, you will create 4 network. But out of those network, there are certain IPs that you will not use. But let's go back to simplicity and just let you know that if you want to create a subnet mask as it is, forget what I just said, if you want to create 2 subnet mask, you need to go Class C and borrow 1 bit and make Class C instead of 2425. So once you do that, now you have 1 network that you can assign to the side of the router, and you have another network that you can assign to this side of the network. And that's how, reason why. You can see all the way down here that interface 00 got the IP address of 192.168.1.1, right? And the subnet mask is what? It's 255.255.255.128. The other side of the network, however, got the IP address 192.168.1.129, and the subnet mask is 255.255.255.128. You need to know this network are different. So this network is not the same as this network. Although it looks in a number, human eyes, if you look at it with your own eyes, you'll think it's the same. It is not the same. It's a different network. The only way for you to find out if you convert them into a binary number and do the AND process. Why I'm saying this? I'm saying this because the routers do not connect the same network. The routers connect dissimilar network. Routers cannot connect 192.168.1 here and another 192.168.1 over here. The router, they don't do that. So all this to you, to humans, looks like it's the same network. All right, they have the same subnet mask. They're really different networks. All right, so here's another really nice video that is again out there, and in this they're showing you creating how we create 2 equal network used by borrowing a single bit, and I'll go over it again. Well, this is, as you can see, 192. Like I told you, is Class C. All right, how I know is the first bit, and Class C has 24 bit. 8 plus 8 plus 8 is 24, and this is the host. Out of the host, we're going to take away 1 bit. We're going to borrow 1 bit. So we're going to have 1 bit for the new subnet mask, and we have 7 bits for what do you call it? For the host. As a result, this one no more worth 24. Now, since you added another one, you're going to add 1 to the 24. Now you're going to have 25. So watch what happened when you borrow 1. You go to your what do you call place value, and you look at your numbers, 2 to the power of 1, 2, 4, 8, 16, 30, 64, and you borrow the highest bit in the network. You borrow the highest bit. Once you borrow this bit and add it to the subnet mask, it'll become 128, and this is your network. This is your custom network, and the rest of them will all become. So now you have 2 network, all right? One network will be 192.168.0, and your second network will be 192.168.128. You may say, how did we get this 128? Remember in the slide before, we talked about this magic number. So what is the last out of here? What is the last man standing in the last bit standing in this new custom subnet mask? The last bit, or the only bit standing if you want, is 1. What is the value of this one? Is 128. So this 128 have become the incremental. And lucky for us, we only when we borrow 1 bit, we only have 2 networks. So the first network will be .0, and the second network will be .28. Again, there's a good video out there. In the course, in the course material, in the Netacad, I highly advise you to go and watch it for further explanations. When we do subnet, we'll follow this very well-known, famous, what you call it, formula. It's called 2 to the power of n. This is when we do it for the host. For the network, it's okay. 2 to the power of n, there is no, you don't take anything. 2 to the power of n for network will work just fine. But for hosts, we need to do 2 to the power of n minus 2. Why is that? Because the rule said the host IP can never be all zeros and can never be all 1. And as you're going to see, when you borrow a bit and you start creating the network, the first IP, the first bits are always as 0 and the last bit is always 1. So as a result, you cannot have the first one or the last one. Like in this case over here, when you borrow, you can see over here, if you borrow 2 bits, all right, if you borrow 1 bit, I'm sorry, you have 1 bit. If you borrow only 1 bit, you left 7 bit for the host. 1 bit, 1 to the new custom subnet mask, and 7 stays. So 2 to the power of 7 will give you 120 IP addresses per each subnet, all right, per each subnet. But you need to do, you can't use all of them. You can't use all 1s and 0. So as a result, you're going to 2 to the power of 7 minus 2, which is equal 126. Again, for the network, 2 to the power of n is what you want. But for the host, always you do 2 to the power of n minus 1. So I repeat again, we'll always exclude the first and the last one, which is the first one is always 0, and the last one is always 1. All right, so you can see here now we're asked to create 4 subnet masks. Well, the first question when you ask to create 4 subnet masks, the question is how many bits I need to borrow to get me 4 subnet masks. How many bits you need to borrow from the network, from the host ID to get 4? Well, it's 2. 2 to the power of 2 is 2 to the power of 2 is 4. 2 times 2 is 4. Now, since again the IP address is class C, when you add 2 and we have 24, you add 2, you have 26. Now, by borrowing this bit, now we have 2 to the power of 6. All right, 2 to the power of 6. We only took 2 bits for the network. So the host will have 6 bits. So it is 2 to the power of 6, which is 2 to the power of 6 minus 2. So 2 to the power of 6 will give you 64, minus 2 will give you 62. And you can watch them right there. I can show you right here. Look, this is all the possible network. By the way, this is network 0, network 1, network 2, and network 3, and now. So there are 4 networks. This is all the possible network. Watch how the first network is all zeros, right? It's all zeros right here, right here. And the last one is all 1s. And we can't use all 1. All 1s is known as a broadcast, and all zeros is this network right here. That's why we don't use it. That's why we have, if you have 2 bits, zeros, if you have 2 bits, you'll have 4 network, they're right here, and those 4 network, the first network is 0, and the last network is all 1s, The new custom subnet mask, because you borrowed 2 bits, the highest bit you borrowed will be 128 plus 64, which is 192. I repeat, you have 255, that's 235. In addition to 2 bit that you borrowed, they are the highest bit. So 128 plus 64 equal 192. Your new subnet mask for all this network will be 255, that 255, that 255, that 192. All right, here's breaking it down in more and clearly. You can see the network that we just created, network 0, network 1, and network 2, created 2 subnet masks. We'll have 26. Now what we did over here, I'm showing you, they want to show you that you don't use the first, you don't use in any given network, you don't, the first bits, all right, the first host ID and the last host ID, you don't use them. As I told you before, the first one is called the broadcast, and the last one is the broadcast, and the first one is this network right here, right there. So the first one is here, the first one is here, and the last one is all the way there, and you can't use them. Why? Because the first one is a network, and the last one. So please remember this rule. When you are creating networks, you can't, subnet mask, the host, you cannot use, and you find in the host for each network, always remember, you can't use the first one, and you can't use the last one. The first one is all zeros. The first one is here, right here. The first one is all zeros, and the last one is all 1s. And the same case for the other ones. All right. In this case, now we're going to go, now that we borrow 2 to the power of 2, we have 4 networks. We want to assign those IP addresses, those networks. You can see that we have enough. There is, by the way, there's one network over here, network number 1, network number 2, and network number 3. By borrowing 2, we have 4 network, although we only need 3 over here. So we decide to use the first network. So we're going to go 192.168.128. This is the network ID. So here, this router is using, here we're using 128. So we gave this router 130 and this router 129. And we went up here and we gave this router .1, 192.168.1.1. And this router, we give it 192.168.1.65. And we have enough to give the other. This is our hosts within the same network, within this network over here, this network. And here, this is our host per this network. And of course, the way you assign IP address to your router is 192 IP address 192.168.1.1, 255.255.255. This is 192. This is router 1. 192 over here, this side of the interface over here, all right, and then the other side of the network is over here. 1 here, and the 65 is over here, and the subnet mask is 192.192. Even the serial interface, which is this over here, the serial interface also has a subnet mask as 192 and get the IP address. Again, I repeat, by looking at the subnet mask, you may think they are in the same network. They're not really in the same network. All right, this is another video that I highly advise you to go and watch. And in this example, they're going to show you how we can borrow 2 networks to create a 2 bits to create 4 network and having /26. So watch over here that by borrowing 2 to the power of 2, we're going to have 4 new network or 4 new subnet. The subnet mask, the magic number is going to be 64. Again, you may say, where do we get this 64? The last standing bit. I know they call it the magic number. I call it the last standing bit. The last high standing bit over here is this one. So this is 128 and this is 64. So as a result, your network will be an incremental of 0, an incremental of 64. So 0, 64 plus 64 is 28. 128 plus 64 is 192. All right, I'm going to stop right here. I know there's a lot more to cover, so I have to stop right here. I highly advise you again to go back to the course online and to watch Dan's video. They will help you a great deal, and I will do a lab.